Good day to you, Prof, and my dear colleague. This presentation is about comparing two algorithm, BST and the B3 algorithm using employee management system. Stella is my name. Okay. I'll be using this content during the course of this presentation. Introduction. Employee management is a platform that enables an organization to keep track of their employee details, personal details, as well as work-related information. And this information are stored in a secure way. Okay, this enables admin activities to be performed in an easier and quicker way. So in this system, we'll be looking at how the HR manager is able to perform the following function: insert, delete, search, update, and view, while the employee can perform this, the view record. Okay, the objective of this presentation is all about this: to implement BST and B3 in C++ for employee record, such that basic operation like insertion, search, updates and deletes can be done. So also want to compare the two algorithms, the BST and B3 data structure. Also want to calculate the time complexity for this operation on the two selected data structure. These are use case diagram. The HR manager is able to manage a record by performing this operation: insert record, delete record, search record, and view record, while employee, on the other hand, can view the record. These are flowchart diagram. We have the stats, the main menu. There's the three operations we are interested in. Basically, the insert, the delete, the search record. Once a record is inserted, insertion is successful. Okay, and deletion, on the other hand, you can delete a record, an employee record, using an employee ID, which is the primary key here. So once the ID is correct, the record will be deleted and deletion will be successful. If the ID is wrong, it will take us back to here, prompting us to enter the right ID. Same goes for search operation. Once you can also search with the right employee ID. Once the right employee ID is entered, record will be displayed. If it is wrong, it will prompt us to enter the right employee ID. Basically, there are differences between BST and B3. Okay, BST is a binary search tree, is a node base that has a right and left subtree. The left subtree is usually lesser than the node key, while the right subtree is greater than the node subtree. There is no duplicate when it comes to binary search tree, and a session is simple. But in B3, is a self-balancing tree. It has the capacity to adjust itself, okay, in an order transversal manner. Okay, so there's no limit to the number of tree. The number of tree is based on the order of the tree. Okay, unlike BST, which has two children, operation is done when the disk is loaded. The leaf must be at the same level. It is used in database management to index a code, like you have an index and you have the pointer, and the pointer that points to the record. Insertion process is usually slower when it comes to B3 because of the multiple child load. This is basically the time and space complexity. This is for B3. We have the average case, the worst case, and this is for our B3, the average and the worst case. These are screenshots. When we run our code, these are the main menu. Once an employee ID and the name is entered, it goes into the database, and this is the session that performs the rotation. Here we use order of 3. Depending on the order that, so once the 3 is completed, any employee ID that you enter, they split, they readjust, they self-balance. That's the rotation part of the code. So here we also test our input with 3 different nodes. The small one is 100. For BST, we have this number. B3, we have this. For 200, which is our medium data, we have this. And 500, which is considered as big because of the processor speed of our system, we have this. And average time for insertion is 5876 nanoseconds, while for B3 is 7253 nanoseconds. Same goes for session operation. The search time complexity for the same number of nodes as displayed here. So the average time for B BST is 1168.7 nanosecond, while B3 is 6498.2 nanosecond. For delete, we also have this, the same. Okay, average time is 4848.9 nanoseconds, while this is 1124.2 nanoseconds. Okay, this is the insertion time graph for BST. Okay, and this is the record showing when our input file was read. This is the average time indexed by ID, indexed by name in nanosecond, is displayed in this graph. So we also have this graphical representation showing the best, the average, and the worst case for insert, delete, and search. Okay, so now from our recommendation is that B3 perform faster in when it comes to basic operation for employee management system, because of its efficient way of storing data, efficient way of searching, and the amount of time it takes to search is also reduced. The amount of time it takes to delete is also reduced. So that's about our presentation. At this point, we want to say thank you for listening.